Hey guys, it is coming to my attention that we have the chain rule coming up in our pre-calculus class, and the way Mr. Keel has it listed, it might actually be a little bit awkwardly worded or awkwardly stated and explained. And I know that a lot of people complain about how he explains things, and this is definitely probably the toughest unit of chapter 3, and since we have a test coming up on that next week, I figured, hey, why not try to explain it in a little bit easier way that I found, and I think it's probably a little bit easier than with all of his dy over dx's, du's over dy's, and just those kind of things. So if you look at number 4 on your pre-calculus notes, that's getting close to one of the more tough problems that we're going to have to do in pre-calculus this year at least, and I know it's coming up on the future quizzes and tests. So what we're going to do is I'm going to take one even harder than that, and we're going to basically solve that one. So what our equation is going to be is you're going to get y equals 1 plus the sine squared of 5x, and you're going to take 1 plus sine squared 5x, and you're going to raise that to the power of 4. So when you have this, you're going to get something that looks a little bit like that, if you can see that. And what you're going to do is you're going to focus on 1 plus sine squared of 5x. That's going to be inside the parentheses. And what you're going to do with those parentheses is you are going to basically take the derivative of what's in there. And we already know that the derivative of 1 is 0, so you don't really have to worry about the 0, or you don't have to worry about the 1. So you're just going to take the derivative of sine squared of 5x. And the only problem with that is that you can't take the derivative of that in that form. So what you have to do is you have to set up something that you can get sine squared of 5x. And the way to do that is to split sine squared 5x into sine of 5x times sine of 5x, which will give you sine squared 5x. And what you're going to do from there is you're going to take it and use the product rule. You're going to take the sine of 5x, and basically you're just going to have that be one part of it. And then what you're going to multiply by is actually not the next sine of 5x. What you're going to do is if you go back to the original equation and you look at sine squared 5x, what you're going to do is take the derivative of the sine squared 5x in a way where it will work to multiply into the product rule, but if you take it the other way, you won't be able to use it to the power of 4. So if you take sine squared of 5x and you do the derivative of that, you are going to get whatever. Well, first of all, let me explain that the derivative of sine is cosine. So what you're going to get is you're going to get 2 cosine of 5x, because you're just going to bring the 2 from sine squared down and then change sine to cosine. And then you just do that to the other side, and you get sine of 5x again times 2 cosine 5x. And what you can do is you can then simplify that to 2 sine of 5x cosine of 5x plus 2 sine of 5x cosine of 5x. And if you add those together, since they are similar and they have common numerator, common denominator, whatever you want to say, you get 4 sine of 5x cosine of 5x. And what that is there you have the derivative of the inside. And what you should get is right there where I have inside, you should have 4 sine of 5x cosine of 5x. I should say 5x, I apologize. And then next, what you're going to work with is you're going to work with the outside of the equation. Basically, if you imagine it as setting it up as y equals u, for example, you can use any letter, but I'm going to use u. If you set that up as y equals u, and what it's going to be is, since there's a power of 4, it's going to be u to the 4th, because you're taking that entire expression of 1 plus sine squared 5x, and basically you're subbing that in with u. And what you're going to do is create another variable, another equation, and you're going to take u is equal to what's actually inside of there. So 1 plus sine squared of 5x. And then from there, what you're going to do is you are going to take the outside again, like I said, and you are going to basically take the derivative of the outside again, and what the outside of basically like u to the fourth, it's going to be 4u to the third. You're taking like x to the fourth is going to become 4x to the third. So what you write that down, and you get 4u to the third, and that's your outside. So as of right now, you should have those two things. The outside, as you can see, is 4u to the third, and the inside is 4 sine 5x cosine 5x. So the last thing to do before you can actually set it up and then multiply and simplify it all out is you are simply going to then go back and you're going to plug the original equation back into it. So you're going to take 1 plus sine squared 5 of x and plug it in for u. So then what you get is you just take the outside and you throw 1 plus sine squared of 5x right back into it with that. And what you're going to do is take that entire equation, multiply it by your inside derivative, which you got before, apologize, it's taking a little bit to write down. And then what you get is you get this equation right here, as you can see. And that's what if you see right here, you're just plugging basically the original u back into what you got for the derivative of the outside, and then you're multiplying it by the entire thing. And that is as far as you're going to have to go for this. It won't be till next year when we get into calculus that we have to do that. So again, if you just go back to the original equation, all you're basically doing is you're taking the derivative of the inside, which is a case of dy over dx. You're just taking the derivative of the inside, and then you're taking the derivative of the outside, which is always going to be u to something. And then you're just going to take whatever was originally in the normal equation, and then plug it into the u, and then multiply the inside times the outside, and that's as far as you're going to have to simplify it. I hope that's a little bit easier than having to list all the variables that you would have to do with Mr. Keel's way. It's very similar to Mr. Keel's way, but for those of you who don't understand, I hope that this helped, and that's all I have for you today.